Okay. I'm supposed to ask each of you who are in person to make sure that nobody has any privacy issues. Yeah. Okay. So this is Math 2341. This is the same syllabus as what I have on Canvas. Okay. Zoom it a little bit. I don't think my office location is important this semester. I'll post the Zoom links for my office hours probably today or tomorrow. Okay, and my office hours would be Monday, Tuesday, and Wednesday from 12 to 1. The textbook, there is both electronic version and printed version available. You just need to buy the electronic PDF version that should have enough information for all of you. Okay. We'll talk about the course a little later. Let me just quickly go over the logistics here. We don't have a cumulative final, so the grades will be just based on essentially 5 tests. Okay, so from test 1 to 5, you could skip 1 if you want to. Not that you should. Okay, but test number 6 is mandatory so that you won't leave town after test number 5. Okay, so you can, between test 1 and 5, you have a choice there if you want to mess up one of them, or test 6 is mandatory. Okay. Test would be of 70-minute duration, and that's why I had that survey going on to schedule the weekly tests. Okay, I think the last time I checked, there were 3 or 4 students more to return the survey response, so please do that when you can. Okay. We don't have anything this week, so we start next week, and then we can have a test every week. Okay. All right, the usual grading scheme of 94 and A and so on. Okay, so nothing surprising there. And if you have any complaints about the course, first talk to me. If you cannot get a satisfactory answer from me, you can talk to the teaching director, Professor Martin Skowiski. Okay. There are a couple of other things like tutoring and other things which I'll post as separate announcements, because if I write it here, nobody would read it. Okay. So I think the College of Engineering has free tutoring available for all their courses, so I'll post those information on Canvas separately. Okay. So that is the main part of the syllabus. Do you have any questions about this? I think this is what people mainly want to know, right? I don't think the name of the teaching director is very important today, but do you have any questions about the grading policy of the class or anything? People online, just feel free to unmute and ask if you have questions. Any questions? All right. Let me just show you we cover almost all the sections and chapters in the textbook. That's a pretty short, small textbook. It's not a gargantuan book if you look at it. Okay. So we start with 2 sections of chapter 1. We do almost everything in chapters 2 and 3. Okay, almost everything. And then the second half of the class, which would be probably around weeks 3 or 4 to the rest of the semester, would be linear algebra, which is here. If you have taken Math 2331, you might find some overlap with what you're seeing here. That's part of the process. Okay, but the linear algebra we'll be doing here would be mostly computational. We are not going to do any theorems and proofs, which is usually a main characteristic of linear algebra. All right, so that is what I wanted to share with you in terms of the syllabus. And you can always email me if you have any questions about any of these. Okay. Back to our normal screen. I hope all of you know how to explore your way around Canvas. The recordings are all under cloud recordings. Okay. So I don't email the recordings to each of you after every lecture. You just need to go and check on Canvas. So all the resources that you need for the semester would be under Canvas modules. Nice workout for me. Okay. I've kind of removed a lot of unnecessary things you don't need in Canvas so that you can kind of focus on just modules. You click on that, you will find everything. So that includes things like solutions to homework, and then any other information that you will be even taking your tests there on modules. Okay. So if you have any issues accessing that, let me know. It should be pretty straightforward. So we just get started here. This is Math 2341. Differential equations, and students usually think about why this linear algebra is even part of this course. Okay, and I'll tell you that in a minute. All right, so this is going to be chapters 1 to 3, and this will be chapters 4 to 7. And for a first timer, these might look like two different courses. It's almost like talking about philosophy and chemistry. So there is probably no interaction going on, but you will see that at some point these two things start to merge into something which is pretty neat. Okay, and that is where mathematics is kind of really nice and useful in terms of applications. So I'll quickly introduce what a differential equation is and why we need linear algebra, and then we will start our material. Okay. So what is let's just abbreviate this by DE for our discussions, because this is what the semester is all about. Okay, so let's not keep on writing differential equations each time. So when you write something like this, x squared minus 3x plus 5 equal to 0, that is what we call as an algebraic equation. And you know how to solve it. Okay, I'm not going to do that. So things like, if you write x squared minus 9 equal to 0, okay, that is another algebraic equation. The reason why it is algebraic is because the solution to this, it's typically some numbers, right? That's what we are used to. Some of them you could solve by hand, some of them you may not be able to solve quickly by hand. You might need some software. Okay, but at the end of the day, you get some numbers out of it. A differential equation, on the other hand, in general, okay, it's not going to give you numbers, but it's going to give you functions as output. A differential equation is an equation with the derivative of a function y, which depends on x. Okay. And if you've been through pre-calculus and calculus, so you know what I'm talking about. Okay, there is a dependent variable, say population depending on time, okay, or velocity depending on time. So y is called the dependent variable, and x is the independent variable. So when you say population varies with time, we don't talk about time varying with population. Okay, so you should know clearly which depends on what. So if you write an equation with the derivative of this variable equal to something, okay, right now we don't know what it is. So maybe some terms involving both x and y on the right hand side, that is what we call as a differential equation. Okay, so an algebraic equation has variables. The differential equation has derivatives of the variables. Okay. The most important difference between these two is that the solution to this would be y equal to something. Okay, this something is going to be a function of x. Okay. it's almost never equal to just a single number, okay, unless you have some very specific kind of problem that you're solving, okay. In general, you're going to get some kind of a function of x, which a lot of times it's difficult to even understand what is going on, okay. That is why we have softwares to plot the results and see what exactly the function means, okay. So that's going to be our main objective in chapters 1 to 3. Okay. So different techniques to solve differential equations. So if your differential equation has just the first derivative, it's called the first order. Okay. The order refers to the maximum level of derivative that you have in the equation. Okay. So a second order equation look like this: d square y dx square minus 3 dy dx plus 5y equal to 2. Okay, that is a differential equation with the second derivative. So this is a second order differential equation. Okay. These are the two main kinds of differential equations we'll be studying this semester. Okay, so first chapter would deal with first order, and the second chapter and mostly third chapter would also deal with second order differential equations. You can also talk about the degree of a differential equation. So if you have dy dx to the power of 3, this is the degree equal to 3. Okay. That makes the equation nonlinear. We are not going to deal with any nonlinear equation. We don't have time for it. Okay. So if you have this to the power of 4, that is degree equal to 4. So our main focus would be to deal with degree 1, which is linear first order and second order differential equation. Degree equal to 1, first order and second order. If you write a random differential equation like this, okay, it's very difficult to say what the solution is, or it's even difficult to say whether there is a solution to it. So we are going to do a very limited class of differential equations, which we can do by hand. Okay, and later on in your engineering or other classes, you might see more advanced differential equations for which you have to use a software or some kind of programming to figure out the solutions. All right, so the two requirements to solve differential equations of this kind is basic calculus. Okay. And I don't expect any fancy calculus here. Okay. You should be able to find, or you should be able to know the derivatives and integrals of basic functions. Okay. So your calculus 1 would be more than enough. I think the part where students struggle is the next one. Okay. High school algebra. Because you're able to do this calculus, but you have to at some point do some manipulations to get the solutions out of it. Okay, and unfortunately, every semester, sadly, okay, this is the part where students struggle a lot. Okay, so if you have basic mathematical, algebraic issues from your past, okay, this will be a time to just review those things and be kind of prepared for this class. I'll be doing some of those examples today. So just to remind you of some of the techniques we need for this semester. Okay. But please don't underestimate this. The calculus is very easy for this course. Okay. If you know the basic derivatives, you're okay. This one, please don't take it lightly. Okay. I cannot teach you high school algebra. Unfortunately, it's too late for that. Okay. So you have to kind of do that yourself. For those of you who are watching it on Zoom, I know this thing is kind of blocking your view when I lift it up, okay, but hopefully when I'm putting it here, you should have enough time to copy it down if you want to. Okay. So we still don't know why linear algebra is required, and that's because in a lot of applications, we have more than one variable. Okay, so if you have, say, two functions, say y1 and y2, which depends on X. Okay? It could be two species whose populations we are trying to find with respect to some outside variable X. Okay? So we might have equations like this: dy1 dx equal to 3y1 minus 4y2 and dy2 dx equal to 3y1 plus 7y2. It doesn't have to be 3, it could be negative 3. That is what you call as a system of differential equations. Okay, instead of having just one differential equation that you had up there, okay, this is a system of first order linear differential equations. And you have probably solved systems of equations like this if you have, say, x plus y equal to 3 and 2x plus 3y equal to 5. Okay. That is what you call as a system of algebraic equations. You can solve for x and y. What if you have more than two variables? Okay. What if you had, say, seven variables and 8 equations? And that is where linear algebra is useful, because it tells you how to deal with systems of linear equations. And the same concept you're going to make use of here in studying systems of linear first order equations. And that is where linear algebra is useful. Because instead of dealing with one variable at a time, which might seem like a good idea if you just have two functions y1 and y2, okay, if you use linear algebra, you can attack all of them at once. You don't have to deal with y1 first and then y2 and then y3. Okay. Linear algebra gives you a very compact and robust technique to do all the variables at once, and that's a very efficient way of doing things. So that is why linear algebra is part of this course. It's not because we are trying to teach some random things during the semester. All right, so that is the course outline. So we will have approximately 3 weeks of linear algebra, 3 weeks of differential equations and 3 weeks of linear algebra, okay, plus or minus. So that is how the course is planned during summer. All right, any questions about the course content? About people online, any questions? You can either type it in the chat window or unmute and ask, okay. Any questions? All right, if you don't, let's start with section 1.3. Okay. I forgot to tell you that all the homework solutions are posted on Canvas. Okay, so if you go to Canvas modules, the solutions to all the assigned homework questions are posted there. The idea is not to read those solutions and think that, oh, I got it. Okay, you have to do it first, make sure that you are comfortable with the process, then compare your answers. Please don't read the answers and assume that you're okay, right? That'll be like if I watch somebody rollerblading and assume that I can do it myself, right? You have to do it. Okay. Mathematics is not a spectator sport. All right. So let's start with section 1.3. This is the most fundamental kind of differential equation, separable. Again, D stands for differential equation. Okay. And we are only going to deal with first order for the time being. So let me just make it clear here. First order, which means only first derivative. And separable differential equations could be linear or non-linear. Okay, both of them are okay. So a differential equation is separable if it is of the form. You can use either y prime or dy dx. assuming that all of you have been through calculus. Okay, so both these notations means the derivative with respect to x equal to f of x times g of y. In other words, we should be able to separate the two variables distinctly so that we could do some manipulations after this. Okay. So if it is of this form, then we can divide both sides by g of y and multiply both sides by dx. Okay. So we can do 1 over g of y times dy equal to f of x dx. That is a part which looks completely separated, right? You have all the y terms on one side, all the x terms on the other side. Okay. And then integrate both sides. Integrate both sides. Don't forget what we are trying to do here. We are trying to solve for y. Okay. This is a differential equation which has a dependent variable. So integrate both sides and solve for y. So as I mentioned earlier, it has got two important aspects to it. Okay. One is the calculus part where you're integrating it, and there's also this algebraic thing which is kind of indirectly there, right? You're dividing both sides by g of y, and then you're solving for y, okay, which involves a lot of algebra sometimes depending on each problem. Okay. So that is the idea behind separable differential equations. So you would integrate this side, integrate this side. Okay, so you will get some function of y here. So this will give you some function of y, we don't know, right? Depends on the function, equal to something from here, capital F of x. I don't know how much your calculus 1 or 2 teachers would have emphasized on the importance of this plus c. In this course, it's extremely important because you're going to miss a lot of information if you don't do this. Okay. So please don't forget it. In some problems, of course, there will be some information to remind you of it, but if not, okay, just put it somewhere in your room. Okay, don't forget plus c so that you know it's very important. Okay. So you get g of y equal to f of x plus c, and if possible, when I say if possible, that means algebraically if possible, okay, solve for y. Because not all expressions are solvable. Okay, depends on the function. There are a lot of functions which you cannot really solve for y directly. In that case, you cannot do anything. Okay, but if you can solve for y and write it equal to something, okay, and that is going to be a final answer. So obviously there are two different ways in which you can write the answer. Okay, so if you can write y equal to something, okay, where the left hand side is clearly y and the right hand side is some function, this is what you call as an explicit solution. As the word says, it is clearly written out as y in terms of x. But if it is not possible, okay, you would terminate at this step here. Okay, if this algebraic process is impossible for whatever reason, this will be your last step, and that is what you call as an implicit solution. So usually the question would specify what kind of solution is expected. If the question says write an explicit solution, okay, do that. If the question is implicit solution, there are different points at which you can stop, okay, and all those solutions are acceptable. And the fact that there is a constant c here means that there are infinitely many answers possible. Okay, we don't have enough information to find c at this point, so there are infinitely many answers possible for different values of c. And the solution is then called as a general solution. The word general means that there are multiple answers possible there. Okay. And in some questions, you'll be given some additional information to find the value of C. In that case, we will be able to get a more unique solution. So right now, when you start doing these examples, you're going to leave your answer in terms of C, and that is called as a general solution. So when you say a general explicit solution, that means you have y equal to something plus C. A general implicit solution means you have some function of y equal to some function of x plus C. Okay. So those are the different kinds of ways in which you could write the answers to the differential equations you're solving. All right, so ready for some examples? Any questions? I should be careful about this thing here. Otherwise, I'll destroy my own laptop. Let's do some examples now. Okay. I'm going to do a few examples which are a little bit harder than what you might see in your homework. Okay. One of the objectives is to show you some of the high school algebraic concepts that you would need this semester so that you won't ignore them or you'll be prepared for them later in chapters 2 and 3. So example 1. Find the general explicit solution for y prime times I don't know, cotangent of y equal to 1. Okay. You write that clearly. Cotangent is the reciprocal of tangent, okay, cosine over sine. So y prime times the cotangent of y equal to 1. Okay, there is no other information given, so you're asked to find the general, which means that it's going to have a plus C. Explicit means that write y equal to something. Okay. All right, so let's start doing this. So y prime is your dy dx times cotangent of y. It's always nice to write your complicated functions in terms of things you know, right? So it's cosine of y over sine of y equal to 1. It's mostly separated because all the y terms are already on the left hand side. Okay, all you have to do is bring the x on the right hand side. So you get dy times cosine y over sine y. You can write it like here equal to dx. Okay, this is what you call as the differential form for the derivative, right? Dy and dx written out as terms. So this is entirely y on the left hand side, entirely x on the right hand side. Integrate both sides. I don't expect you to do a lot of fancy integration in this class. There is one technique that I want you to, or two techniques, but one of them is mostly what we need. Okay, how do you do this left hand side here?
By
Substituting, all right. U equal to sine of y. So if you don't know U substitution or if you forgot, okay, please, this will be a time to just review it. We need that a lot. You'll get a chance to do it in your next week's test. So I'm just telling you beforehand. Okay. So U equal to sine of y. So du equal to cosine of y dy. And I hope all of you know why it is U equal to sine of y and not U equal to cosine of y, because the other one does not work. Okay. So hopefully by now all of you are comfortable with this technique. So we have the integral of, so u is in the denominator here, so it's going to be 1 over u, okay, it's not u, it's 1 over u du equal to integral of 1 dx, which is this x. Now I want you to tell me if I forgot something. Yes.
plus C.
Plus C. Okay. So just make that a habit. And I hope all of you know how to find the integral of 1 over u. It's the natural log of u. Always put an absolute value to be careful about the possibilities where u could be positive or negative. Okay, so it's ln of absolute value of u equal to x plus c. And u is sine of y. Okay, so it's the ln of the absolute value of sine of y equal to x plus c. And let me try to kind of keep it the same area there. Now, if the question was asking you to find an implicit solution, this would be a place to stop. Okay, because we have got something there, but here we are trying to get an explicit solution, so we need to go further. Okay. How do you get y out of this? This is the algebraic part of the that was too fast for me, but let's just slow down. So what will be the next step to
taking the exponential.
okay, take e to the power of both sides. So raise both sides to the power of e. So what you said is probably right. I just needed to go through this step by step. Okay. So it's e to the power of ln of sine of y equal to e to the power of x plus c. Because e and natural log are two mutually cancelling functions. Okay, so we can cancel this and this. And remember that once the logarithm is out of there, there is no need to put the absolute value anymore. Okay, the whole point of the absolute value was to protect against the natural log. So this is going to be just sine of y equal to e to the power of x plus c. Okay. Now, in this course, we will be traditionally doing this little bit of an algebraic trick. Okay, and I know that is why he probably said the answer a couple of steps ahead. Okay, so you can split this into e to the power of x times e to the power of c, and you can call this as a c by itself. Okay, because e is a number, c is a number, e to the power of c is a number. Okay, so instead of writing it as e to the power of x plus c, it's traditionally written as c times e to the power of x. Okay, especially when you do applications for this, you'll find it more convenient if you write this instead of this one. Okay. Almost there. You're still looking for an explicit solution. So y would be the arc sine of both sides. Okay. So y equal to arc sine of c e to the power of x. That is the general, which means there is a c, explicit, which means y equal to the solution for the differential equation. Okay. Arc sine is the same as writing sine inverse, so whatever is convenient for you. Okay. The reason I'm not writing sine inverse is because sometimes students confuse it with the cosecant function. So to avoid such unnecessary bloopers, okay, you can write arc sine. So my main objective there was to remind you of the u substitution method. Okay, if you have forgotten it, please review it. We need that for the semester. All right, any questions on this? Online, any questions, any issues with able to read the writing or anything? If you don't speak up, I won't be able to know. So if you have any issues, please either unmute or chat. Okay. All right, let's do a few more examples then. So I want you to do the next one yourself. Example 2. Oh, God. Sorry, I had it here and somehow. Sorry for this awkward silence. Maybe I'm not going all the way down, that's why. 2020. Here we go. Example 2, find a general explicit solution. This is an easy one. Dy dx equal to x square y minus 4 plus y minus 4x square. Take a few minutes and try to see how to separate it, and I think once you separate it, things are pretty easy. Can somebody online suggest how to start this problem in terms of separating, just to make sure that people are there? It's okay to be wrong, just 45 of us here, so nobody's going to laugh at you or anything. So just suggest something to factor out y and minus 4. Good. So you can write this as y times x squared plus 1, okay, from the first and the third terms, and then you have a minus 4 times 1 plus x squared. Good. So that's a very instinctive kind of thing once you do these kinds of terms, high school probably, okay, to factor out common terms. Okay. What next? Something is kind of inviting you to do, right? Yeah.
Factor x squared plus 1.
Yes, x squared plus 1, 1 plus x squared is the same thing. So you can write this as y minus 4 times 1 plus x squared, or x squared plus 1. All right, now it is kind of ready to be separated, right? You can divide both sides by y minus 4 and multiply both sides by dx. Okay. So separate. You shouldn't be integrating unless you get something clearly separated out on both sides. Okay, you cannot have mixtures of x and y terms. That's not something we can do in this course. All right, integrate. That's a little bit of a glimpse of high school algebra there, but okay, may not be high school, maybe middle school algebra to some of you. So the left-hand side, just like what we had earlier, it's just the natural log of y minus 4. Okay. On the right-hand side is pretty straightforward. The integral of x squared is x to the power of 3 over 3. Integral of 1 is not 0, it's plus x plus c. So not a lot of drama here, right? Just raise both sides to the power of e and move on. Once again, I'm just trying to make you get used to this process of e to the power of c equal to some other constant. Okay, so this is c times e to the power of x to the 3 over 3 plus x. You don't have to write your c equal to e to the power of c. Okay, you don't have to write that and kind of convince me, or but if you really want to write it, you could do it. And then add 4 on both sides. So y equal to 4 plus c e to the power of x to the 3 over 3 plus x. The fact that there is a still that constant c there makes it general, and the fact that we were able to find it explicitly as y equal to makes it explicit. All right. So those were two relatively easy questions. Okay. Now let's do some slightly harder ones, because that's what I promised you. Any questions before I erase anything here? Yep.
Why is less than 4? Doesn't that mean you have to flip it?
If y is, well, it depends on what the initial conditions were, right? So when you do these problems, you're assuming that y is greater than 4, not equal to 4, depending on what you're doing. Okay. So the y less than 4 is not, in problems where that is a requirement, it will be clearly stated that y is greater than 4 strictly. Okay. That's a good question. Yep. All right, let's do the next one. Okay. Number 3, find a general implicit solution. So my requirements are a little bit lower. For dy dx equal to y square plus 6y plus 34. So this is one of those examples which I'm doing. Okay, first of all, it's because it's separable. Second thing, to remind you of a very important algebraic thing that you would need later in the semester. Okay. Well, let's do the separation first. That's easy, right? You just need to bring all the y terms on the left-hand side, x terms on the right-hand side. That should be straightforward. Is there anything wrong with what I've written here? Yeah. Divide what? So what should we divide by? The entire thing? The entire thing, or? Subtract y squared plus 6y. That's not going to, that's not what we are trying to do here, right? 1 second. Can anybody who has not answered yet try to tell me if this is okay or not? No. Or am I violating some laws here? Mathematics plays with very strict rules and laws, right? Am I doing anything wrong here? I think somebody already raised a hand. So you have to divide by the whole thing. So what does that mean? Should I divide the 34 as well there? Is that what you meant? All right. Is that what you had? You cannot just take bits and pieces of things that you want. Okay, mathematics doesn't play favors. So either you divide the whole thing or not. Okay. You cannot just say, oh, I'll just divide by one piece of it because that's what I like. Right? Okay, so what you said earlier, it's okay, but that won't help with our solution. Okay. All right, let's integrate it. Just trying to remove any of the wrong mathematical notions in your mind. Okay. So if you believe this is true, let me know. So I had this thing here, okay, and I thought, oh, just split them out. Who cares?
Well, you
So he
can't
said
put up the
yes or
time
no.
here.
What do you think, online people? Might want to unmute if you are saying something, or it's
You can't.
false. Okay? You cannot do such a thing because you can only split the numerator, not the denominator. So if you believe in such things, please change your beliefs. Okay. So what do you do then? How do you integrate this without Wolfram alpha? Yeah. By parts, I don't know if that's going to work. For integration by parts, we need some very strict formats to, not the logarithm, because again, logarithm means you are trying to split things out here. Factorize the denominator. That's a good suggestion. Can we factorize this? If that was a possibility, we could use that. Can we find two numbers whose sum is 6 and the product is 34? I don't think so, right? So let's just keep that to the side. Set u equal to, I got a lot of answers, so I'm still looking for that magic golden nugget. So this one unfortunately won't work because this term is not there. Okay, so by the time you create that, it's going to be, there is one algebraic technique you've learned in high school, which probably your teacher told you is very important. It has got to do with this square here. If you cannot completing the square, okay, very important technique. Please, if you forgot this or if you've never seen this, this is the time to review it. Okay. Complete the square. Not just for this section. This section you might be able to do without completing the squares in most of the problems, but in chapter 3, you would see this is an extremely important technique. Okay, and we don't have time to kind of go back and forth a lot. So if you forgot this, please go back and review it. Okay. It's not a very complicated thing. What you do is take half of that 6 and complete the square. Okay. So completing the squares means you have the integral of dy divided by half of 6 is 3. I hope you remember what your high school teachers told you. You use this to complete the square, y plus 3 whole square. But then when you do it, you know that y plus 3 whole square, the freshman's dream is that you have y squared plus 9. Is that true? What else is there? Plus 6y. Yeah, okay. I hope all of you believe in those things, right? Okay. So y squared plus 6y is here. Okay. You only have 9, so to make up for the remaining part, to make it up to 34, we need to add a 25 here. Which looks like it's a lucky day. 25 is also a perfect square. Okay. So it's equal to integral of dx. All right, so that is a good progress there. Okay, so we kind of explored a lot of possibilities. We couldn't factor it, we couldn't use substitution. Okay, so at last it looks like completing the square looks like a technique that might help us get through this problem. Okay. All right, make some room here. Let's put u equal to y plus 3. So du is dy, dy is du. Okay. So we have the integral of du over u square plus 25 is 5 square equal to the integral of dx. That brings us to the next question. What is the integral of 1 over u square plus 1 du? Tangent, it's not exactly tangent, it's tangent, the arc tangent, right? So it's tan inverse or arc tangent of. If there is any fancy integral that you need to know, it's probably this one, okay, if you want to call it fancy. I don't expect you to know secant inverse or anything, but tan inverse is a pretty frequently occurring one. Okay. And if you had something else instead of 1 there, integral of 1 over u square plus a square du, okay, you just need to scale it by a. So it's going to be 1 over a tan inverse of u over a c. Okay, so if a is 1, you still get back this. Okay, for any other non-zero value of a, that is what you have. That's something you can kind of keep it as a note in case you want to use it on a quiz or a test or something. Okay. So this would be 1/5 tan inverse. Again, tan inverse is a arc tangent, not the cotangent of this. Okay. Arc tangent of u over 5 equal to x plus c. And since I only asked for an implicit solution, you just need to plug in u and you're done, right? So u is y plus 3, so it is 1/5 tan inverse of y plus 3 over 5 equal to x plus c. That is what you call as general, because you have a c here, implicit because you're not trying to write y equal to something explicitly. So that is what the question asked you. So my main objective there was to remind you of completing the square. Lift this up. All right. Any questions about that example? Again, don't be surprised if you find your homework questions to be significantly easier than this. Okay. So try the next one yourself. Dy dx equal to y square plus 4y. Find a general implicit solution. Okay. Okay, so I did the separation step for you, which is nothing remarkable. Okay. The question is what to do after this. Any suggestions for what to do? Yeah. So one of the things about completing the square is that we need a last term. Here it's almost like a +0. So completing the square might be a little bit of a right. Subtract what? Oh, you're trying. Well, you could do that. I think it's going to be a ridiculously hard problem to solve at that point. There's nothing wrong about it. Okay, so that's where integration gets a little bit tricky. So if you're talking about y squared plus 4y plus 4 minus 4, is that what you meant? Or minus 4 plus 4, so plus 4 minus 4, is that what you meant? Yeah, then you only have integral for u squared plus 1, not minus 1. And if you don't do any, yeah, you have to do those complicated trig substitutions, which I don't think most students have done. Yeah. U square minus 1, that's a square root of u square minus 1. You're talking about a different. If you're talking about just this one, this is not arc sine. This one is arc sine. I think that's the confusion here, right? Yep. Yep. Yes. I heard up to that. Let's pull out y out of it. Okay. Let's just take it slow. So the integral of, it's not a constant, it's a variable. So that's this y times y plus 4. So that is probably the most natural thing to do, right? There is y common there, pull it out, and that's equal to the integral of dx. Then what? Here comes the second algebraic technique you need. How do we separate these two terms, one there and one here? There is an official way of separating these two to two distinct terms. What do you call the technique? Partial fractions. Okay. So I think there are a couple of students online who got that. So use partial fractions. Believe me, chapter 3 is all about this. Okay, so if you forgot this, please go back and review it. Okay. Partial fraction is the legal way of separating two terms in the denominator. Okay. And this is probably the most basic case where we have two linear terms. So we have 1 over y times y plus 4 is equal to a over y plus b over y plus 4. In chapter 3, we'll also do a few more complicated cases, but this is the most basic of them if you have two linear terms. Okay. So our objective is to find a and b so that this equation is true. Okay. So there are two ways of doing it. Method 1. So clear the fractions. So which means that you can write this as 1 over y times y plus 4. You can just cross multiply this. That's going to be 8 times y plus 4 plus b times y divided by y times y plus 4. And if you have done this before, you know that the denominators are going to get cancelled out. Okay. So essentially you get just 1 equal to 8 times y plus 4 plus b times y. So that's the good thing about practicing a lot of these. You know what to expect in each step. Right? So don't forget what we're trying to do here. We're trying to find a and b, okay, and then plug it back in and then finish the integration. So this method is a pretty clever way of finding this a and b. Okay, it's called the Heaviside's cover-up method. Heaviside was a self-taught electrical engineer who had a lot of really clever techniques to find complicated mathematical stuff. Okay. So Heaviside's idea was this, to just hide one term at a time. Okay. So here, in this case, suppose you just hide this one and just focus on the first term. Okay. So you can set y equal to 0, for example. It give you 1 equal to 4a. So that gives you a equal to 1/4. So give some values for y so that one of them would disappear. Okay, that is why it's called a cover-up method. So you're just covering up one. What will be another value you could plug in here? -4. So similarly, y equal to -4 gives you 1 equal to -4b. Okay, remember you're finding a and b, not y. So b is -1/4. So if this works, it's a pretty clever method to do it. Okay. It may not work all the time. That's a problem. Okay. There are some cases where you may not find such numbers which will kind of cover up terms effectively. So that is why you should also know method 2. This always works. Method 2 is pretty non-fancy. So you write 1 equal to a times y plus 4 plus b times y. That is what you had there. Just expand this. So it's going to be ay plus 4a plus by. And that's equal to a plus b times y plus 4a. So just very basic algebra here. Okay. Now the left hand side is just 1, which means you had 0y plus 1. Okay, there is no y term here, right? So if you compare the coefficients of both sides, sorry for writing it from right to left. Compare the coefficients. So the coefficient of a plus b would be 0 because there's no y, and the coefficient of 4a on this side would be 1. Okay, so we have 4a equal to 1 and a plus b equal to 0. So this gives you a equal to 1/4 and b equal to -1/4. Both will work, both will give the same answer. The second one is more reliable because you don't have to think about this kind of tricky stuff about figuring out numbers that will hide one at a time. Okay, this will always work. Either way, we have this. So we have a equal to 1/4 and b equal to -1/4. So this integral here becomes integral of 1/4 over y minus 1/4 over y plus 4 dy equal to the integral of dx. So no matter which method you did for finding a and b, ultimately you get the same step at this point. Just integrate term by term. You're only asking for an implicit solution. Okay. So it's 1/4 ln of y, absolute value, minus 1/4 ln of absolute y of y plus 4 equal to x plus c. You could, if you want, do some algebra and find an explicit solution, but the question is only asking you to find implicit solution here. Okay. So that is an acceptable final answer. So those two techniques that I just showed, okay, both completing the squares and partial fractions, we would need it later. So please don't just see it today and then kind of put it away. Okay. Any questions on this? All right. Now let's see what to do with this value of C before we introduce more other techniques you need. If you are an applied math person, or if you're an engineer or a physicist, okay, leaving answers in terms of the C is not a very good idea, because that leaves you with infinitely many answers. So we need to solve a special class of problems called initial value problems. All engineering problems are classified into either initial value problems or boundary value problems, okay, because of both space and time constraints. So here we are just going to worry about initial value problems. Okay, the word initial here refers to typically t equal to 0. But that's your choice, right? You could begin at t equal to 1. Nobody is going to question you. So sometimes a specific value of y of 0, this y of 0 is the t equal to 0 value here, okay, or x equal to 0. Sometimes a specific value y of 0 is given. Find the value of c. Now we're going to lock it down to one value or one solution. Okay, we're not going to have infinitely many answers anymore, and this is what we call as a particular solution. So this gives so the two kinds of solution. It's either general, which means the answer is going to be left in terms of C, or it's particular if you have a unique value for C and there is only one answer. But everything else is the same. So it's just a question of finding this extra thing C, and the calculus and algebra and everything is pretty much the same as what we were doing. All right, so let's do maybe a couple of examples, and then we will conclude with that. So example 1, this one I have to look for my notes, otherwise I might end up with bad numbers. Example 5, solve the cube root of xy times dy dx equal to 1 with y of 8 equal to -1. So in this case, 8 is the starting time. Okay. And the question is to find particular explicit solution. So I'll do this, and then I'll let you do the next one yourself. Okay. I hope all of you through your math journey up to this point would have seen the cube root being written as an exponent of 1/3. Okay. So this is x to the power of 1/3 times y to the power of 1/3 dy dx equal to 1. You can always split an exponent written as a product, not as a sum. Okay, so if it is the cube root of x times y, you can write like this. Okay, if it was the cube root of x plus y, we are out of luck. Okay. All right. Not a lot of drama here. Okay, just separate and integrate. Probably one of the easier problems you have done today. So divide both sides by x to the 1/3 and multiply by dx. Hope all of you agree. Okay, no tricks here. And integrate both sides. I hope all of you believe in this result that integral of y to the power of n dy is y to the power of n plus 1 over n plus 1 plus c. Okay, what is the only exception here? Yeah. Yep, n is not 91. For all other values, this is true. That includes 1/3, negative 1/3. Okay. Whatever strange values you have in the exponent, this is always true. So this is y to the power of 1/3 plus 1 is 4/3, divided by 4/3, that's 3/4. Equal to x to the power of negative 1/3 plus 1, which is 2/3. Yep. Divided by 2/3, that's going to be 3/2 plus c. Now you could either solve for y all the way and then plug in those values there, or you could plug it in here. Okay, it's up to you. So you're given that y of 8 is negative 1. Just to plug it in and solve the value, solve for the value of c. So y of 8 equal to negative 1. Make sure that you understand what this means. When x equal to 8, you have y equal to negative 1, okay, not the other way. So we have negative 1 to the power of 4/3 equal to 3/2 times 8 to the power of 2/3 plus c. I think these are things you could easily solve by hand, not use a calculator and struggle with exponents and so on. Okay. Negative 1 to the power of 4 is positive 1. 1 to the power of 1/3 is just 1. Okay. Eight to the power of 2/3, you could write as 8 to the 1/3 square. 8 to the 1/3 is the cube root of 8, which is 2. Okay, so by the time you kind of put it in your calculator, I think you could easily solve this by hand. But please do these kinds of calculations. Don't leave your answers like this. Okay. So this is 3/4 times 1. That's 3/4 equal to 3/2 times 4, which is 6. Plus c. 6 is 24 over 4. So c is 3 minus 24 is negative 21. So instead of having an infinite number of values for c, that condition of y of 8 equal to negative 1 gave you a specific value for c, okay, which means now your solution is unique. So now you go back here, plug in the value of c and finish it off. So we have, you don't have to write we have, 3/4 y to the power of 4/3 equal to 3/2 x to the power of 2/3 plus c is minus 21 over 4. And I'm asking you for an explicit solution. Okay, the particular part is already done. We found the value for c. You just need to find the value of y somehow. Okay, so multiply both sides by 4/3. So you get y to the power of 4/3 equal to 4/3 times 3/2 x to the power of 2/3 minus 21 over 4. Which actually is not too bad. This is 2 x to the power of 2/3 that's going to be minus 7. The left-hand side is y to the power of 4/3. So how do you find y? Just erase this. That's one way of doing it, right? But that's not the right way of doing it. So what do you do with that 4/3? You have to subtract, or I know your mind is going through several things now. What do you do with that 4/3? Yeah.
Maybe multiply the exponent by 3/2.
3/4, right?
Yeah.
So you're multiplying this exponent and this exponent by 3/4. That way you get 1 here and you have 3/4 here. So don't do any hiding business. This is your answer. Not saying that all the problems will be able to get a clean answer like this, but sometimes you will. Before you guys leave for today, one more example. So kind of lost count here. Example 6 coming up. dy dx equal to 3x square times e to the power of negative x to the 3 minus y up here, okay, not down there. Y of 0 equal to 0. I promise you this is the last example for today. Can you try that and see what happens? So this is all from section 1.3. Okay, so please later today just get started on the homework, the textbook, and then compare your answers with the solutions I posted on Canvas. Okay. Well, I thought it was an easy problem, but then suddenly I think I don't know what to do. Okay, the y is sitting up there. So what do I do to separate the y and then do my calculus or whatever? Any ideas? Yeah. Okay,
X squared times e to the minus x cubed over y, and then it would be dy times y.
okay. We just try to understand what you probably had the right idea, but when I heard it, probably. So you have 3x square e to the power of negative x to the 3 over y like this. Something is missing there, right? If you do this, I think you have the right idea to kind of take it to denominator, but something should be there. Yeah. E to the y. Then it is right. So if you have, doubts about these things, let me know. Okay. Now you can bring this 1 over e to the y to the left-hand side. That will become, so if you want to be more clear, you have dy dx, whichever is helpful for you. E to the power of negative x to the 3. You could also have written like this. So both are correct because of the law of exponents you learned in your middle school. Multiply both sides by e to the power of y. So you get e to the power of y dy. And also multiply both sides by dx, which seems to be a common theme for all these problems. And if you have done some calculus 1, I'm hoping that you see the pattern now. Okay. So if you are going to integrate both sides, the left-hand side is not too bad. Okay. The right-hand side seems to be kind of well set for doing what? Yep, your substitution. Because you have 3x square sitting here. Without this 3x square, you couldn't have done it, right? It's a 3x square, which made him say it's the chain rule that is working backwards here. So du is negative 3x square dx. Or if you just want 3x square dx, then it's negative du. All right, so the left-hand side, the integral of e to the y is that. All of you agree, right? Or do you sense something wrong? Something terribly wrong? Yeah. Just e to the y. Okay, so hopefully all of you remember that. And anything else? Only problem is I have y of 0 equal to 0. To do that, I need something to do here. Plus what? Plus, okay. A lot of things to keep in mind. You have to know the integral of e to the y, you have to know plus c. And this is just negative e to the u, okay, because it's again the integral of e to the u, and u is negative x to the 3. So as I said, it's just a chain roll backwards that happens there. So you have e to the y equal to negative e to the power of negative x to the 3 plus c. Now you can plug in your condition when x equal to 0, y equal to 0. Okay. And don't forget that e to the 0 is 1, not 0. So that gives you 1 equal to negative 1 plus c. Okay, which in one look looks like c equal to 0, but it's not. Okay, c is 2. Because of the well-known property that 2 minus 1 is 1. All right, that is not too bad. Okay, so we have e to the power of y equal to negative e to the power of negative x to the 3 plus 2. The only thing is I don't know how to bring that y down. I'm thinking. Yes. Log ln to the logarithm to the base e, right? So y equal to ln of, just to be safe, put the absolute value of 2 minus e to the power of negative x to the 3. Okay, so e log e. Yeah. Okay, I think that'll be a good place to stop for today. So we will continue this tomorrow and also do a few applications. Okay, and probably just start 1.4 depending on how fast we go. Let's stay back if you have any questions about this or the course in general or anything. In the meantime, I think there are 4 or 5 of you who have not done that survey for the test scheduling. Please do it. Okay, I know who you are, but I don't want to call names out. So just do it. It takes only 1 minute, and unless it's some kind of a political reason that you're not doing it, just do it. Okay. All right. I'll see you tomorrow, and let me know if you have any questions on Canvas.
Thank you.
Thank you.
I think I also
Thank
sent you an
you.
email just to say that you have not done it. So you could either check your email or check Canvas under modules or check both. You just need to pick a time for the, it's not a very complicated thing. You don't have to solve any equations or anything. So. All right, any other questions, online people? All right, I'm going to stop the